Welcome to Tech Talks with Wallace Hennis Associates. I will be your host, Steve Martin, coming live from the New Jersey location. To give you a little background to start off with, I'm a mechanical engineer working with the company for 25 years. Our company itself has 2 locations. We've been in business for 95 years and have 72 employees. So we're quite a large firm. Average tenure of employees been working here is 16 years. So quite a bit of knowledge in our company. We're here to work with you, folks. We have 2 locations. Both locations have a warehouse along with an office. In those warehouses, we have material in storage to be able to work with you. Anything for emergency usage, to be able to get equipment out to you relatively quickly, from pumps, air separators, expansion tanks, boilers, water heaters. We're here to work with you. So we have 2 locations, staffed with both offices, and both have warehouses in order to get material to you fairly quickly to help you help your customers. Who we are, what we do, and how do we achieve success. Here's a few of my fellow employees that are working for the company. Some of you may have worked with them in the past, or hopefully, if not, we'll be working with them in the future. They're part of the 72 people that we have working, everything from engineers, master plumbers, contractors that have been in this business for a long period of time, working as a representative now. So we like to tout the 360 experience. What is the 360 experience? Great question. It is, we are looking to start with the developer who has a need in his building, either to upgrade or to install a new system. So we would like to meet his expectations and exceed his expectations as to what he is looking for. We do this by working with architects, engineers, general contractors, mechanical contractors, service contractors, developers. We start from the beginning, work the job all the way through to the end, back to the developer to meet and exceed their expectations. So they want to work with you, work with us in the future. Excuse me. One of the arms of the 360 experience is the hydro source. Internally, we have a staff of engineers, CAD operators that are willing to work with you, size, to select equipment that's going to meet your system desires and needs. We'd like to ask questions. Why? Because it uncovers exactly what you're looking for, so we can meet and exceed what you're looking for on your system. We will provide drawings, AutoCAD drawings for details to give to developers, for engineers as well. Hydro Max, another facet of our company, is to optimize the equipment that is installed on the systems. In both locations, we have 4 service technicians that are available to go out and program and set up each one of the boilers, water heaters, to align pumps, to work on VFDs, to program, have them set up properly in the field. We like to maximize the equipment so it works properly and functions as needed and as expected. Also, you can see in one of the pictures there is a plate and frame heat exchanger. Condensed water systems in the city are notorious for being dirty, for dirt getting into those systems. Where's that dirt going to end up? In the cooling tower and in the plate and frame heat exchangers. Thus, we offer a service where we'll go out and power wash the plate and frame heat exchangers to be able to get that dirt and grime off it. And in essence, bring it back to where it was when it shipped out of the factory in order to ensure optimal performance. Our technicians have been certified at the factory to work on these units. Thus, we know them inside and out for assembling and disassembling and putting them back together. Another facet of our arm of our 360 experience is the HydroFab. Before the project even starts, we could be prefabricating skid equipment that can be plug and play into your building prior to even construction starting at the job site. In essence, we're cutting down the construction cycle in order to make it shorter. We can prefabricate these skids using the equipment that we know, understand, and can install properly. We know the equipment, how it's to be installed properly, can work together properly. We can prefabricate all of this off-site at a lower cost in order to work with you. Our manufacturing partners. We have quite a few partners that we work with. These are factories that are located across the country that we have been trained on. We know inside and out how these systems work, how their components work, and how they will function together. Thus, we know the details, ins and outs of this equipment. Please work with us so we can work with you. A few project spotlights. These are located in our territory. A few of these are high-rise buildings. There's some low-rise buildings. One of them is one of those projects we talked about, 99 Hudson, has 22 prefabricated skids that were assembled off-site prior to the construction cycle even starting. Thus, we could plug and play, drop them in the side of the building, have everything all ready to go. By the time the contractor got up to that floor, the skid could be dropped into the floor as well. So our conversation today was balance. Why balance a system? Well, in essence, let's take a look at a sample building here. Here we have a pump size for 600 GPM at 150 foot of head. Let's assume that each one of these A, B, C, D, E, and F are a different floor of the building. At the inlet to each one of those floors, there's a thermostatic control valve shown in green. They operate based on temperature. They will allow flow through that coil or not allow flow through that coil, or somewhere in between, depending on the temperature setting to make sure they're satisfied. Well, if we put a pump on the system at 600 GPM, 150 foot ahead, and we open up those valves, all 6 of those valves, well, the coil on the lowest floor is going to get more water flow than what that air handler was designed for. In this case, we pick 100 GPM for each one of those air handlers. Well, if I was to do the math on this, you can see on the right, each branch, if we wanted 100 GPM on the top floor, the one on the bottom floor would require 191 GPM in order to force that water all the way to the top of the building to get 100 GPM through the top coil. Well, not an effective way of operating a pump that was designed for 600 GPM at 150 foot ahead. So what do? We put balance valves on the discharge of each one of these coils. In essence, we force the water from the bottom floor up to the top floor by closing it off. As you can see here, we put a pressure drop across each one of these valves. Excuse me. By closing off the valve on the bottom floor of the building, we are in turn forcing the water up to the top of the building to go across the top coil and back down. By restricting water flow at the bottom portion of the building, it's forcing the water up to the top. This is done here in this picture with a manual balance valve. The original engineer designed this pump to work at 600 GPM at 100 foot of head, so it's going to operate at this point on the curve. Will it? Depends on the system. If the pressure drop in the system that it's installed on has a lower pressure drop, it'll operate further out on this pump curve. If the pressure drop in the system with all the valves open is up here, well, we're going to get less flow. That pump will operate somewhere on this pump curve on this blue line showed here. Where? Depends on your system. Well, if we put balance valves on each one of these coils on the system, we can effectively determine where it's operating on that pump curve. By closing off the valves on the bottom here, we can force the water all the way to the top portion of the building. But what happens if one of the valves on the floors is satisfied? It doesn't need any more cooling or heating, so thus the valve closes off. Well, we're not getting any flow to this coil. Our pump is still on. Where's the water going? Through the other valves on the system. So if we take a look at that pump curve again, yes, we are getting less water flow because one of the valves is closed off, but now our pump is riding back on the pump curve, effectively giving us more head pressure than we needed. Well, you don't necessarily need to do that, but here we're going to take a look at another system where we have a terminal unit on it. We have supply going up, water going through the terminal unit into a three-way valve. Well, if the water doesn't need to go through the three-way valve, this port can close off and allow water through the bypass. We typically recommend putting a circuit setter on the bypass so that the pressure drop through the bypass is the same as going through the terminal unit, effectively giving us proportional balance going across a three-way control valve. But in order to balance that whole floor, you also need one on the return side coming back. So what do we do when we have more flow and higher head pressure than we need? Well, we can vary the speed of the pump by putting a DP sensor on it. Excuse me. A DP sensor measures the pressure from the supply side to the return side and comes up with a differential pressure. If we met that differential pressure and we're starting to exceed it, well, we can tell the pump to slow down, effectively reducing the speed of the pump, reducing the output in terms of GPM and head pressure. Why? Because we don't need it. Because this valve up here is closed, but the other floors of the building do need it, and they don't need as much head pressure in essence to get the water flow up here. Thus, the system is proportionally balanced with manual balance valves, because it will proportionally reduce the flow through each one of the balance valves with the reduced flow going through the coil. Well, to take a look at that, we can get a little bit more detailed on it with that variable speed drive and control valves on the system. We have one valve closed here on the system, but the rest of the valves are open. We can monitor this system and the valves that are open and closed and regulate that VFD to operate the system curve up and down in order to maintain the exact flow and pressure needed. Well, systems get a little bit more complicated. Here's a different type system. Here's a pump on a system feeding water up into the supply line, and it's going across here into the return leg. This is known as a reverse return system. What is the difference? Well, the first coil being supplied here, the water is going through it and coming to the return side. On the return side, it's the last one feeding back into the return header back to the pump. So in essence, we have equal lengths of pipe into this coil to this coil here. So if you measure the length of pipe through here and measure the length of pipe through here, it would be exactly the same. So on systems where the pressure drop of these 4 units is exactly the same and the pressure drop to the coils are the same, it's reverse return system, thus and can be balanced with a reverse return. It's a lot more forgiving than a direct return system. We're not showing any balance valves here, but yes, I would recommend putting a balance valve on a reverse return system. Why? Because not every one of these are going to have the same pressure drop. You need to balance this system because the pressure drop through this coil may not be the same as this one, or this one, or this one. It may be different size coils on it. If it's not exactly the same size, it will become a problem. Thus, balance valves are needed here as well. Different types of balance valves. Let's start off with the manual one. This one's been around for the past 50, 60 years, manufactured by Bell & Gossett. We have ports on top of it. These ports allow us to read the differential pressure and temperature going across these valves on it. Thus, if we read the differential pressure, we can know what the pressure drop is the valve is. And here we have a dial on it. We can tell what percentage open or closed that valve is. This is what's known as a calibrated balance valve. A calibrated balance valve will measure the pressure drop across the valve based on what position it's open and have an accurate flow reading. I warn you, be careful, because there are manufacturers that are not calibrated balance valve that are supplying these out in the system. So I warn you, your caution. On the larger sizes, these are flange type valves, similar to the one that we were looking at before, manual balance valves with pressure ports, integral readout ports across the valve, along with a dial that we could measure the pressure for how open or closed this valve is, and we'll give you a chart that would tell you the exact flow going through the valve. Very easy to work with. Well, what if you didn't want to go through the process of manually balancing those on the system? So we got a little bit smarter and came out with an automatic balance valve. This allows water flow to go through the valve, and as the pressure starts to build, it'll close off the ports on the bottom here, restricting the water flow going out to the valve. What does that do? If you want 5 gallons a minute going through this valve, regardless of what that pump does, it's only going to give you 5 gallons a minute through this cartridge here. Thus, balance contractors, there's not a lot for them to do out in the job site with the automatic balance valves. Why? Because if you set this valve at the factory to give you 5 GPM, that's what you're going to get out in the field on it. No need for adjustments. Here's a take a look at the inside of it. There's an internal spring that opens and closes this valve to restrict the water flow going through the ports on it. As you can see, one with an open is going to allow more water flow through than one with a closed. The spring is compensating for the change in pressure by the pump. Here it is, take a look at it with a ball valve on it to shut off, and that automatic cartridge inside here. It does have pressure ports on it, so you can read the pressure on it to make sure it's in the operating range of the valve. which is on the low side is 40 pounds or 4 pounds, on the high side is 60 pounds. Excuse me. Well, people said, what if I set it at the factory at 5 GPM? I get it out in the field and I actually need 7 GPM. So we got a little bit smarter, and then we came out with this valve. This has a red dial on it. This dial allows us to set the flow rate out in the field. This one will only allow 5 GPM because it was preset from the factory. This one, by adjusting the handle, we can increase that to 6 GPM, 7 GPM, whatever you need to maintain through that coil. So, and thus, it's still an automatic balance valve that can be changed, the setting on it in the field without taking the valve apart. Here you can see the flow range. We need an initial pressure to get these valves to operate properly. This line here represents 4 PSI. Once there's enough water pressure coming up to the valve at 4 PSI, all the way through 60 PSI, through this whole range, the valve operates fairly accurately in terms of flow through that valve. Here you can take a look at some of our competitors that do make the similar type valves. Their flow range is a little bit all over the place depending on who you're working with. So I caution you, be careful. Work with a credible company that has accurate readings on their valve and published data. As you can see on the Bell and Gossett circuit setter, this is the 1 1/4. At 4 pounds differential, yes, coming up to it is a little bit of a fluctuation between 4 and 5, but as we get into that 4 to 60, this will represent 60 here. You can see how accurate that valve is in maintaining 4.75 GPM. At here, we're roughly about 4.5, so yeah, it's a little bit of fluctuation on the early side of it. Well, we got a little bit smarter with those automatic flow valves. We said, you know what, why not combine those with the two-way control valves? And this way we can control the flow and water flow GPM through this portion, and we can control the temperature on this one, and we can do it all in one valve. So the bottom portion here allows you to control the flow rate. The top portion allows you to control the temperature. Here's a look at the internal portion of the valve. The water flow goes in through P1. It circles around the valve. It goes through that spring portion and out to the discharge. The spring portion down here controls the flow rate. The top portion controls the temperature. So as you need to increase or decrease the water flow through the valve, you can do that based on temperature up here. The bottom portion will still limit the maximum flow through that valve. So there's pros and cons. Pros on putting automatic balance valves on a system, they require less valves in the system. Why? Because we're combining the two-way control valves, the automatic flow control valves, all into one. They have a higher accuracy. As we can see, it was that dead man was pretty close on those. Lower installation costs because you have less valves to install. Lower test, adjust, and balance costs. Why? Because there's not much for the balance contractor to adjust on an automatic balance valve. He's not putting manual balance valves where he's going to have to adjust them and spend a lot of time in the field making sure you get the right flow rate. Well, we're also going to have less pumping capacity requirements because those valves will close off as you're getting more water flow through the valves. As it's trying to push more water flow through, the valve will close off, pushing it back, forcing the water up to the top portion of the building, and thus you can reduce the speed of the pumps. Automatic valves increase your accuracy by 10% as a rule of thumb. The cons is, yes, the initial cost is a little bit more, but you're saving it based on all the balancing that you don't need to do out in the field. Also, the pressure drop. We do have that initial pressure drop of 4 PSI to get these valves to work properly. So, thus, I would caution you, manual balance valves, automatic balance valves that you can adjust and have temperature control are available. We at Wallace Ennis are here to work with you. We want to make sure that what we're putting on the system is going to work. It's going to work properly. It's going to work as your designed intent, and it's going to exceed your customer's expectation. I think you would agree that investing in a quality product like you've seen makes sense. So please contact us, reach out to us. There's 72 employees in our company. One of us will be able to help work with you and either on the design phase, on the selection phase, on the pick out of the actual balance valves for the system. Please work with us. We're here to work with you, and I thank you for your time and attention this afternoon. Enjoy the rest of the day, and I will hope to hear from you soon.